Hi guys, in this video we will discuss about the forward and backward difference table for the numerical interpolation. And here in this video we only concentrate about the forward and backward, that how to create forward and backward difference table. So let's begin our discussion that how can we start, that how can we create the forward and backward difference table. So say here that if we consider a real valued function, like y is equal to f of x, consider a real valued function y is equal to f of x, and it is known for set of n plus 1 equispaced points, set of n plus 1 equispaced point, namely we can say that is x0, x1, x2 dot xn. Equispaced such that, and this will be there is a relation that is like xi is equal to x0 plus ih. That is defined by xi is equal to x0 plus ih, and equispaced means that is the difference of each point, that is like the difference of x1, that is x1 and x0 is equal to x2 minus x1 is equal to x3 minus x2, and dot all the difference are same, and it is defined by h. So I hope it is clear to you. And now if we consider the corresponding, and we can say that if we consider the elements are like xi comma xi plus 1, and here this h is known as the space length. This h is known as the space length. And this is a closed interval, and here you can say this is, you consider the interval, closed interval like x0, x1, x1, x2, and dot xn, xn minus 1. And now if we consider it by like this, that if we consider that corresponding y0, the functional value x0, y1 is equal to f of x1, and yn is equal to f of xn. And here this x0, x1, x2 dot xn, these x values are known as arguments. These are known as arguments, and the corresponding values y0, y1, y2 dot yn, these are known as entries. Now I am going to discuss about what is the forward difference and how can we create the forward difference table by one example. So here I am just showing you that how can we find the forward difference. So here I am just head with forward difference table. Here I write that is the forward difference table. Forward difference. So how can you find the forward difference? That is the difference between y1 minus y0, y2 minus y1, and at last yn minus yn minus 1. These are known as the forward difference. These are known as forward difference. And similarly, not only the forward difference, this is known as the first order forward difference. First order forward difference. And now the question is that how can we find the first order forward difference, and what is the notation? That is, here we can write that del y0 is equal to, you can write y1 minus y0, del y1 is equal to y2 minus y1, del y2 is equal to y3 minus y2, and if we want to find del yn, that is yn plus 1 minus yn. And in general, we can write, that del yi is equal to yi plus 1 minus yi. So I hope that you will understand it, that in general, the forward difference table, we can create that del yi is equal to yi plus 1 minus yi. So this is the first order difference. This is the first order forward difference. So now in the next question, next part, we will discuss that how can we find the second order? That is by second order difference, we can find it by like this. That second order difference means del 2y0. Del 2y0 means we can write this is del y1 minus del y0. And del y1 means we know this is y2 minus y1, and del y0 means y1 minus y0. So from here we can write this is y2 minus 2y1 plus y0. Similarly, we can find del 2y1. Del 2y1, how can we find? That is, we know that del 2y1 means del y2 minus del y1. And del y2 means we know this is y3 minus y2. And del y1 means y2 minus y1. So from here we can write y3 minus 2y2 plus y1. And similarly, we can find del 2y2 and del 2yn. Now I'm going to discuss about how can if this is the second order difference. These are the second order difference. These are the second order difference. These are the second order difference. So now how can we find the third order difference? How can we find the third order difference? We can find the third order difference by, that is del 3y0. So del 3y0 means we can write that del 2y1 minus del 2y0, and del 2y1 means already we find y3 minus 2y2 plus y1 minus and del 2y0, that is y2 minus 2y1 plus y0. So from here we can easily find it, that is y3 minus 3y2 plus 3y1 minus y0. And similarly we can find the del 3y1, del 3y2, and so on. So you will try. And now I'm just going to discuss with you that in the functional form, how can I write it? So in the functional form, we can write it by like this, that in the functional form, we can write it, that is del f of x is equal to f of x plus h minus f of x. So now the question is that how can we find this is the functional. This is the functional form. So now the question is that how can you find the second order, that is del 2f of x. So del 2f of x means we can write del f of x. And so from here we can write del of f of x plus h minus f of x. We can write it very easily. And now from here we can also write that this will follow the distributive law, that is del of f of x plus h minus del of f of x. So from here we can write from here that f of x plus 2h minus f of x plus h minus, and from here we can write f of x plus h minus f of x, and if we simplify we can write f of x plus 2h minus 2f x plus h plus f of x. So this is, now by one example I will show you that how can we find the forward difference table. So let us discuss about that how can we find the the forward difference table. So here I'm just going to share with you my one example. That is, write the question that construct the difference table. Construct the difference table. Or the construct the forward difference table from the following data. So how can we? So here we write the following the data, that is x and y. So this is here, right? This is 0, 5, 10, 15, 20, 25, and this is 7, 11, 14, 18, 24, 32. So now I'm going to discuss with you that how can I find the how can we construct the forward difference. See here that if we find that this is what is the value of x0, that is 0, x1 5, x2 10, x3 15, x4 20, and x5 25. So this is the question. So this is the, and see here that the difference between every point for every x is same. So now we can use the forward. So now we can construct the forward difference table. This is the basic of constructing the forward difference table. That is, the difference between each point of x will be same. And here the difference is same. So we can say that here h is equal to 5. So now here I'm going to construct the table. See here that I'm just write here, this is x. This is y. So here I am just write, this is the value 0, 7, 5, 11, 10, 14, 15, 18, 20, 24, and 25, 32. Okay. So now here I am going to find the first one, that is the del y. So here del y means we have to find the difference of this 11 and 7, that is 4. Next, the difference of 14 and 11, that is 3. Next, 18 and 14, that is 4. 24 minus 18, that is 6. And 32 and 24, that is 8. So this is the first order difference. So now how can you find the second order difference, that is del 2y? That is the difference of this. That is the difference between 3 and 4, that is minus 1. 4 and 3, this is 1. 6 and 4, that is 2. And 8 and 6, that is also 2. So now we are going to find del 3. What is the del 3? Now we have to find the difference of these four points. That is 1 minus of minus 1. That is 2. 2 minus 1 is 1. And 2 minus 2, that is 0. And now I'm going to find the fourth order. That is del 4y. And so what we get from here? That is, this one is minus 1. And this one is also minus 1. And here del 5y. And here the difference between is 0. And now the question is that this is the forward difference table. So I'll just repeat again that how can I find, that is del y means you know y1 minus y0, y2 minus y1. So this is the del y0, this is the del y1, this is the del y2, del y3, del y4. This is the del 2y0. You can write it here. That is this, and this is x0, x1, x2, x3, x4, x5. And here I'm just changing the color here. Okay, this one Here, this is the del y0, or you can say this is y0, this is y1, this is y2, this is y3, this is y4, this is y5. And now here you can find that this is the del y0, this is del y1, this is del y2, this is del y3, this is del y4. This is del 2 y0, this is del 2 y1, this is del 2 y2, this is del 2 y3. This is del 3 y0, this is del 3 y1, this is del 3 y2, this is del 4 y0, this is del 4 y1, and this is del 5 y0. And here the question is that where we can stop the forward difference table, where this will come to a single point, and then we'll stop the forward to construct the forward difference table. So I hope you understand that how to solve, how to find the forward difference table. So thank you for watching the videos. Thank you.